Oh, West Coast. Okay.
International.
Oh, okay. Oh, yeah, behind the student center. Yeah, okay. Okay. I hope that please discuss with the others and then make sure that you have all the materials for class this semester, because 2 weeks later we will start for midterm exam. Okay, but don't worry about the exam. Okay, especially for this IUP class. Okay, I will try to continue my course. Actually, before we have been share and discuss about what kind of industrial engineering disciplines and the competency of industrial engineering, and then what the definition of industrial engineering, and then and we try to focus again, to break down, go into detail, and what kind of scientific method we implemented in industrial engineering. Okay. So let me refresh again about the definition of industrial engineering again. Please remember these definitions during your study in this department. Okay. Industrial engineering is about concerned with the design, improvement, and installation of integrated system of man, material, information, energy, equipment, whatever. Yeah, man, machine, material, method, money, environment. Yeah. And then it draws upon specialized knowledge and skill in the mathematical. That's why you need to strong mathematical knowledge in this area. Yeah. Not only in industrial engineering, in the engineering, of course, we need the mathematical competencies, very, very important. Physical also, and then social science. So we try to combine again, beside the engineering knowledge and the social science knowledge, together with the principle and method of engineering analysis and design to specify, predict, and evaluate the result to be obtained from such a system. So be mind about what kind of the system. So we need to know what the definition of system. Yeah. Sorry. So this is about the system. Please remember again what the definition of system. Yeah. Because if again I remind you about when you compare with the other departments, for example mechanical engineering, so they are focused about all about machines engineers. Going to the electrical engineering, all about electricals.
Yeah.
Civil engineering, all about building infrastructure. That's the outcome of this competency. And what kind of industrial engineering competency and the outcome of the industrial engineering competency system? We try to, again, the definition before, we try to design, analyze, like that, and evaluate the system. So what kind of system? So we need to know the definition first. What of the system? System is a unit with a certain structure consisting of collections of elements, entity or subsystem that interact with each other in harmony or in oppositions. Yeah, please focus in this caption. Okay, harmony or oppositions. Interact in this definition not only must be harmony. Sometimes the elements interact opposite, but they are interactions. Okay, not only positive, but sometimes they interact with negative perspective. Yeah, that's interactions. Yeah. Simulation and in an integrated manner with a certain mechanisms to realize certain goals. They must have goals. So the keyword is system, collection of elements. They interact, either harmony or opposite, and they have goals. That is the keyword. What kind of a system? Oh, sum of elements. They interaction is order, either positive or negative, but absolutely they have the same goals. That's a system. Okay? Certain goal by turning input and producing output and then they have boundaries to man. You cannot fix all the system at the same time. Of course, you have the boundaries. You have scope to make sure that what kind of area you can fix the problem. It is similar when you come to class. You open the door and then you see all the equipment of this class. We have many elements in this class. We as the human, infrastructure, table, chair, LCD, yeah, and then whatever, your phone, your book, pen, something like that, that's element. So we cannot focus in all that at the same time. For example, maybe I focus in your workstations. I met with the chair and then these tables. That is the small things system in a big system. So we need to make sure what kind of the system we focus. Okay, understand?
Yeah.
Good, nice. Just raise hand if you have any question, okay? So, based on that's definition, also we have the perspective, sound perspective of the system. First is about the functional perspective. Second is about structural perspective, and third is hierarchical perspective. What kind of the difference between the three of that perspective? You can see these illustrations. It is the functional perspective. We have input, and then this is the system, and it is output. They have own functionals. It's order. Okay, this is the process. Input, process with the system, and then you have the output. And B is the structural perspective. Why they call this as the structural perspective? Because they have the step structural. Yeah, between its orders. Input, yeah, some structure, and then they try to make some circular. The process, okay, in the system. And then the last is about the hierarchical perspective. Yeah, they have, we have the big system, and inside of system also have the small system. Same like I give you example when inside the class we have the big system, and then this is the small system. Okay, yeah. This is the hierarchical perspective. And also, this is the big system. We are the system. I am as the lecturer, and you are the participant. That's the system. And then you in your infrastructure. That's the system. Okay? Good. So that's why we need to know about the hierarchy and decomposition structure of the system. In Yoder's word is like when you see picture in your phone, you try to zoom in and zoom out. This is the decompositions. When I see this room, I try to zoom out, so I see the big picture. But if I want to see the small things, small system, subsystem, I try to zoom in. Oh, I see that humans, chair, and the steps. We try to decompositions to make sure the small elements contribute to the big systems. What kind of mechanisms inside of the big system? That's interact positive or negative, but to make sure that they have they all the same goals. That's the system. Okay? So we need to break down about the structure. In the system, we have two perspectives, two approaches to break down the system. First is the product breakdown structure, and the second is work breakdown structure. What's the difference between the both of that breakdown structure? The first thing, focusing about the breakdown. So based on breakdown, what kind of the segment, component, sub-component, assembly under the part. The same question in the first meeting in the class. I asked you, if I order to you, please make this chair 1,000 pieces, and I give you timeline 1 month from now. I give you $1,000 to produce 1,000 pieces of this chair. So the first thing, what you must do, that's things. You need to break down the structure of this chair. What kind of the part I can try to make the product or the produce by ourselves, or I try to invite suppliers. Yeah. So segment, or we have the plastic, and then some screws, and then ini apa ya maksud saya? Foam is the element. So all you produce by on yourself depend. If you want to produce by yourself, for example, these plastics, so you need to provide machines how to produce this plastic. For example, I need cutting machines. When you provide this by cutting machines, you need to invest to buying the machines to provide this one. When you buying the machine, you need to provide human that have competency to operation of the machines. That's the implications. Yeah, until we know the part and then what kind of this part we can produce or we can have from the supplier or something like that, and we assembly maybe, and then the products we get the same specification with the orders in the first. Yeah. So this is the physical element, good or surprises, concept or abstract, and tangible or intangibles. And the other side, we call it WBS, WBS, work breakdown structure. If you want to playing in the project area, I mean the project manager or project management, you must know about this one. All project managers, if they true project manager and know about the knowledge of project manager or project management, they must know about how to work with them structure. What kind of the activity, what kind of the benefit of information and resource allocation, what kind of the program, what kind of the project, what the functions, what kind of the process, how to operate, what the task it means like job descriptions. When you invite something to join to the system to work with you, make sure that they have own job desk. Okay, the task. And then what kind of work element? Same with you. What kind of work element when you join this class? Book, pen, that's work element. What kind of your task? Task is you are students. So just follow the instruction of your lecturers. That's a text. What kind of operations? You try to explain it in front of class, and you get the materials. Okay, process. Function, of course, based on this goal of this class, of this course, and the others. Okay, this is the difference between product breakdown structure and work breakdown structure. Okay. Yeah. So back again in my example before, when going to the class, or the other example is going to the market, traditional markets. When you going to the traditional market, maybe you can invite Ahmed going to the traditional markets, for examples, okay? Going to the traditional market, and then you see a lot of people, a lot of elements in the market. Fish, vegetables, they sell fish, they sell vegetables, something, whatever. Yeah. And because they have a lot of elements, either they interact with the others, yeah, positive or negative. Make sure what kind of system of interest going to the market. What the definition of, sorry, this is Indonesian, I'm forgetting to translate. Wait a second. Okay, I will try to translate, okay. System of interest is a system that focus about what the saya mau translate. What of the focus you going to the system? I mean that what of your interest to the system? When going to market, I try to focus in one workstation on one of the one of mini store, not all stores, but one store or one workstation. Okay. So because they have a lot SOE in the one market, maybe I might focus in the mini store of fish, and then other focus in the vegetables store. They have own interest. That's problem. It's okay. Depend on your interest, but make sure based on your interest, its orders. Make sure of what kind of the problem domain you focus based on your system of interest. What is problem domain? Yeah, refers to all the information that defines the problem and the constraint that limit the solutions. So when you focus in one, for example, this class, and focus on the process lectures this class. This is one of the system of interest. I am as the lecturer try to explain the material, and you student try to study about what kind of material I explain in class. The interactions between of the element. I am element, you element, this element, this is element, this is element, your child is element. And then what kind of problems during we discuss like this? Oh, maybe one of the problem domain is the materials maybe not really communicate. Or I think the class is very big. It's not comfort for students. Maybe just make this small class. That's a problem domain. What kind of problem that give the impact to the goals? What of goal this class? What of goal is this process? What kind of goals this process? I mean this is our system of interest, okay? Lectures. What of the goals?
To understand the material.
That's good. That's the goals. So make sure what kind of not ideal position that might impact the material not deliver very good in the class. I think the temperature is may impact. The temperature of the air conditioning might impact them, not comfort. So they distract our goals. So that's one of problem domain. The others maybe the tears is not very comfort to the student. That is problem domain. So we try to collect what kind of the problems. After we got the sum of problem, so we try to make solutions. Based on all problems, we need to make sure what kind of the critical problems. Perhaps we got five problems. Based on the five, what the critical problems? So we have the limit solutions. Again, I told you before, we cannot fix all problems at the same time. So make sure what the priority, what the critical problems, that first things. That's why you need to make sure what of the system interest and then what kind of the problem doing. Okay? Good. Yeah. So if you want to analyze the problem domain, sum of terms, you need to focus about these issues. First, stakeholder analysis. The second, risk analysis, requirement analysis, opportunity and constraint analysis, system and element interconnecting structure, rules and the other restrictions. For example, other restriction maybe during this class. Oh, because Indonesia rain very rainy day, so noise of my sound to explain to you. So maybe we can make this room is pengkedap suara atau apa ya? Apa? Sound, no, I mean kayak di ruang band itu. And maybe we try to design this class is very small, and then make sure that all sounds outside cannot directly go into inside. So keep this very silent class maybe, and then when we discuss, the sound is very clear, not don't have this distraction from the outside. That's one example when we want to know what kind of the restriction or rules of this class, something like that. Yeah, and then behavior, system of behavior, and mechanism that like I mentioned before. Okay. So based on this problem domain analysis, the part of how we know how to learn about the scientific method, one of very important thing is stakeholder analysis. What kind of the stakeholder analysis? Yeah. So, for example, when you try to develop or design a business, like maybe Amazon, the apps Amazon, or apa ya? Maybe you have example of the application that you usually use. eBay, or going to booking.com, maybe something like that. Booking the hotels or the ticket of flight, something like that. Okay. When you try to build the applications or startup application, something like that, the first thing is make sure who is the players has to exist that in the system. Why this is very important? Because when you try to invite all the players to the system, make sure who is the player can support and who is cannot support. who can support, so you can invite them to your system as part of elements in your big system. Yeah. In system stakeholder, we have system owner, the party who holds the authority to make decisions regarding the selection of system improvement solutions. The second is system user, the party who implement the decisions. System customer, who feels the impact of the implementation of decisions, and system engineer, who research, analyze, and design the system. Yeah. This is the terminology of the system stakeholder. Okay? And based on that definition, we try to develop the models. The models based on, before we discuss about how the definition of the system, what kind of the stakeholder, how we design the system, so we need the models. What the definition, what kind of the model? Models is, again, representations. Focus on this keyword, representation, the real system. That symbol represent characteristic and behavior of the system. So when you call that model is like prototype, and then when you try to build some infrastructure like airport or this campus, we have the mini maquette or apa ya? Apa mas? Teorama ya atau model. Jadi like prototype is the models. Make sure that prototype is represent the real system, the existing. That's the model. Yeah. So that's very important things. Yeah. What kind of model and system that represents the existing or real system. Yeah. And how to develop the models, how to create the system. Again, we need to scientific method to implement it. What kind of the scientific method? This is the definition of scientific method. Scientific method is a method of finding answer to questions based on investigations by collecting relevant data. Focus on that collected relevant data through observations, experiments, and or literature studies to test the hypothesis, build to unscientific reasonings regarding the questions and rationalizing the answers. So based in this framework, I always remember the student that this is way of life, not only in this class, not only as a student. This is way of life. Why? Because I try to make sure that when you graduate from this course, whatever the situations, whatever the conditions, when you see the system, when you see the problem, the first thing is don't judge the problem based on your assumption only or subjective. Don't try like that. Okay, you need to build the assumption or hypothesis based on relevant data. So please remind this what I say to you. In the third years or in the sixth semester and the seventh semester, when you try to running the final text or thesis, this is very important. when you write down the background research or introduction, make sure that in your introduction you have relevant data. Some students, senior students, when come to me, try to propose their topic of final research and they don't have relevant data, go back to the file.
So for relevant data is based on fact.
Yeah,
Based on fact.
based on fact or historical data. Later I will explain to you what kind of data. But make sure that you have data. We are engineer. We are not politician, like just assumption, whatever, but they don't have strong data. Make sure what kind of the data. Okay?
Ini berdurasi.
Sure. Okay. This is very important. So whatever the situation in your life, make sure that your assumption based on your actual data. Don't try build the assumption based on your subjective, but you don't try to test your hypothesis. That's why you need to learn about statistics later in the fourth semester. You need to construct your hypothesis, test with the experiments. What kind of procedure working based on analysis data, draw conclusions, and the last is communicate the results. Okay. So this is the step of scientific method. We have 6 steps. First is X equations. Define the scope of interest, identify symptoms, and diagnose causes. The diagnose causes is like, as mentioned before, assumptions, your hypothesis. All people have owns assumption. It's okay, but make sure that assumptions have background data, strong data, and valid data. Okay. Next question. And the second is do background research. What kind of do background research? Investigated preliminary evidence. Again, evidence. Study theoretical fundamental. You can search the literature that's mentioned the same problem when you ask in the first step. The third, construct the hypothesis. Define objectives, specify requirement, plan, program schedule. Step 4, conceptual framework. You build the models, or you try to develop the algorithms, or hypothetical statement. Step 5, analyze the data. You mean like prototypes, experiments, testing, proving, and the last is about the summary and how to communicate the summaries. This is the scientific method. So before you make decision in this step, make sure you have running this step. So before you make decision in your life, make sure that you have the construct, and then you have the framework, and then you have the data. This is very important. Step 5, you have the data. Okay. Okay, and then and this is, I very like this picture. Yeah, please remember this picture, because it's very usefully when you running the final project. So project design, capstone designs, and thesis. First, identify need, the problem, something like that. Second, formulate the problem. I mentioned before, we have a lot of problems. You have a lot of alternatives. Third, develop a solution for problem. Don't try to jump to this step or just focus on this solution. No way. Make sure what kind of basic need, what kind of problem, and then what kind of the critical problems. and then we have lots alternative. So we choose the alternative solution based on the critical problem. Don't try to whatever I want to use this method. No way. Make sure what the problems. You have the data. That's important things. Because a lot your senior students, they focus on this step. Whatever the problem, I must use this method. No way. I must use the solution. No way. Make sure that what's the problem and then what's of the supporting data. Okay? Because I'm very excited and very sometimes scary when you try to implement your study in real system like this case. Yeah. When we try to develop this one. Yeah. Stakeholder perspective bias on solution and problems. Why? This is the explanation. First, you can see this one. What the system user state. System user state like this one. Kalau ayunan itu apa ya bahasa Inggrisnya? Swing. Yeah, this swing. Yeah. This is system user state like this one. And then what the system owner want. Oh, I want like this one. Yeah. And then what does a system designer design? System designer like this one. It doesn't, maybe like it doesn't make sense. Okay. It's totally different with system user state. And then what the system builder makes, very confused. Yeah. And then what does the system analyst imagine? It's not imaginary, it's imaginary. And then what the consultant describe was, the consultant of business always make sounds very wow. Yeah. Consultant business describe like this one. Okay. What is budgeting for procurement? No way. Just only apa tali? Rope, yeah. Rope. Yeah. And then what what the provider promise? Yeah. And then what is scheduled delivery? Yeah. What installed? What is documented? Nothing documented. What the supporting system has been accessed? No way. What is charged? So the bill come to you very high cost. Yeah, and then very important. What is really need? This is the goal of the system, based on basic need. It's totally different way. Consider what the system user state in first time, and then actually what the system is, the basic need of the system is what? The specifications. The goals is the same, swing, but the specifications, characteristic difference. So focus in this one. Whatever the stakeholders have own perspective, but again, make sure that your stakeholders have the same goal based on the real need of the system. This one. Okay. Good. Okay. So, Father asked before, what kind of the method of collecting data? Census, retrospective study, observational study, and design experiment. What kind of census? To collect data or information from all members of the populations. It's not sampling. It is census. So total population. Retrospective study to collect data or information that occurred in the past. We use historical data. Third, observational study to collect data or information that is currently occurring in the actual system now. And the last is design experiment to collect data and information through experiments that have been designed in advance. Okay, that's the part of the collecting data. You will learn this one going to detail in third semester. The course is statistical industry. Statistic descriptive. This is the observational study, and then please try to remind this one about data quotients. Beware and be careful about fake, manipulated data. Data from unreliable source. Please be careful. This is the critical issues. Don't try to manipulate data. When you try manipulate data, your integrity is zero. This is the critical case in this department. Don't try to manipulate data. Okay? Okay, any questions? Next, let's play with the Lego. I will try to learn about design. Okay, let's open. Take the all part Lego in your table. Make sure that you have 6 bricks. 6 bricks. 6 bricks. 1, 2, 3, 4, 5, 10, 6. Make sure you have 6. Good. Okay. First, actually, all of you have the same input. Have the same part. Exactly symbols. And the text is please build the dam, not dog, dam. Please build the dam. I understand? Dam. I'll give you the whatever. Free. Focus on your models.
Okay.
Don't compare to the others. I will give example to Ahmed. Wait a second, Ahmed. Build the duck. Okay, this is the duck. Ahmed. That's the duck. Okay. Okay. Focus on your models. Whatever. Don't compare with your friends. I give you 2 minutes. Build the ducks.
What the?
Finish? Focus on your models. Don't try to compare first to your friends. Just focus on your model. Focus on your perspective. You have own perspective about the duck. Finish? Okay? Good. Okay. Yeah. Finish? Okay, yeah. Please show your duck to the others, each others. Any of you have the same exactly models? Any the similars 100%? No? it means that you have own perspective. We cannot make to try to hard each order has the same traffic, no way. That's the system. But when I focus on my first direction, make with the duct. First thing, make sure the characteristics of the duct. What the characteristic of the duct? Any of you in your brakes part not represents the characteristic of the duct. What the characteristic of the duct? And so see your models. Is represent the characteristic of the duct?
Yes.
Good, nice. Yeah. What the key message is, even you have the same input, but you have own perspective, so the process make that output different. So there is no wrong designs. There is no wrong designs. Because what? Because you have own perspective. It's others. But make sure that when you try to build the model of the ducts, what the characters of the ducts, what the specification of the ducts? Two. The mode and then the foot of the duct. That's the character of the duct. If your model is not represents the two characters of the duct, so there's something problem with your imaginations of the ducts. Okay? So actually you have the same input, same part. What if the input is different? How about the process and how about the output? It will be biased. So many designs maybe not really represents what the order in the first time. Okay? Yeah. Even your input is maybe different, not specific like this one. So the probability the output, the same output is very biased. Yeah, that's life. Okay. Okay, you understand?
Yeah.
That's the key message that I need to. Yeah, this one good. They have the mode and the foot. That is characteristic of the duct. But we can. Memaksakan itu apa ya? Yeah, we cannot force all the participants make like this one. Exactly, no way, because they have own perspective. Okay, even you have same input. What is the different input? So the output may be so biased. Okay, good. Back to the plastic. Any questions? Any questions? Please collect all to the plastic. Okay, I think that's enough for today because I have meeting on the 2 o'clock. I need to rush them. Okay, any questions? Oh yeah, please going to the recording, Miss Berlian, and then every class make sure that you fill the absence document.